Okay, so basically stoichiometry is used if you have the quantity of one compound, to be able to predict the quantity of another that maybe you're going to produce. Okay, so we're going to use an example. Alright, so we've got an aluminum nail, and we put that into a copper chloride solution, and single displacement reaction is going to produce copper and aluminum chloride. Aluminum's got a 3+ charge, chlorine's got a 1 negative, so if we drop and swap, AlCl3. Now we have to go balance it. Okay. Alright, aluminums are balanced, coppers are balanced. We have 2 chlorines and 3, so we need to put a 2 here and a 3 there. That'll change our coppers and our aluminums. So there's our complete balanced equation. So let's say we had 2 atoms of aluminum. That would produce, in this chemical equation, 2 atoms of copper. Let's say we had 2 moles of aluminum. That would produce, oops, not 2, sorry, 3. That's the whole point of it. And if we had 2 moles of aluminum, that would produce 3 moles of copper by looking at their coefficients. Alright, if we did 4 moles of aluminum, that would produce twice as much, so 6 moles of copper. Alright, what about this? If we had 4 grams of aluminum, would that produce 4 grams of copper? No, and the reason is they weigh different amounts. So what we're going to have to do in this case is we're going to have to convert grams to moles, then go from moles of one compound to moles of the other using their what's called mole ratio, and then finally back to grams. Okay, so we're going to modify our grams to moles, moles to molecules a little bit, and we're going to go grams to moles just like we've done before, but then I'm going to put molecules down here. Okay, so just change things up a little bit. Next, we're going to put moles here to grams, and then molecules. Alright, so what we can do is kind of a roadmap so that we can figure out where we're starting and where we're ending. So let's go with our 4 grams of aluminum, and what we're going to try and figure out is how many grams of copper would that produce. So here's what we're doing on a mole roadmap. We're starting at grams of aluminum, and we're going to go from grams to copper. So first step is to go from grams of aluminum to moles. So we're going to convert to moles. Alright, 1 mole of aluminum on top, and the molar mass of aluminum is going to go on the bottom, is, looking on the calculator, periodic table, sorry, 26.98 grams of aluminum. Okay, grams will cancel out. Alright, next step, we're going to go from moles of aluminum to moles of copper. That is the only new step we have, and that comes from our coefficients in our balanced equation, whatever 2 we're looking at. So, what goes up must come down. So 2 moles of aluminum, okay, and again we got that from the coefficient. 3 moles of copper go on top, come from that, we got that from our balanced equation. Okay, so that step right there is the mole ratio. It comes from the coefficients of your balanced equation. Next, we're going to go from moles of copper to grams of copper. So we know how to do that. 1 mole of copper, and put the molar mass of copper on the top. So 63.55 grams of copper. Okay, so let's cancel out our units. And we're going moles of copper. and we're left with 14.1 grams of copper, and we'll give a couple other sig figs there, so 4.00 grams. Okay, so that's how we're doing it. Use this mole roadmap for every single calculation that you complete, and we'll do another example. Okay, let's say we start at a different place. We start with, let's go ahead and start with moles of aluminum. So let's say 6 moles of aluminum, and what we want to do is we're going to convert that into molecules. Okay, and then what we're going to do is we're going to go ahead and figure out how many molecules of copper that would produce. So here's what we're doing. We're starting here, moles of aluminum, and we're trying to get here now to molecules of copper. You can do any two compounds. I'm just using aluminum and copper because they're easy with the molar mass. Okay, so first step is to convert moles of aluminum to moles of copper. So again, that comes from the coefficients of our balanced equation. You can do any two compounds. We could do copper chloride to aluminum chloride. Okay. So from our equation, 2 moles of aluminum is equivalent to 3 moles of copper. And then what we're going to do next, we're going to go from moles of copper to molecules. So 1 mole of copper is 6.02 times 10 to the 23rd molecules. Alright. And once you do the calculation, it comes out to be 5.42 times 10 to the 24th molecules of copper. Okay, so the last part would be percent composition. Percent yield. And what percent yield is actual yield divided by theoretical. Okay. Alright, whenever you calculate with stoichiometry the amount, this is your theoretical. Okay, so if we were to calculate the percent yield, it would look something like this. Let's say the max we can recover is 14.1 grams. Okay, and then that would be our theoretical yield. And let's say we only recover maybe about 10 grams. Okay, we divide those, and that will give us our percent yield.